Ever wonder why some buildings stand tall while others crumble? Or how engineers map out vast lands for constructing highways or railways? The answer lies in a seemingly simple yet profoundly important process: surveying. Surveying, in essence, is the science of determining relative positions of points on or near the Earth's surface. It is integral to various fields, from civil engineering and architecture to archaeology and even space exploration. The surveying process can be classified into many types, such as land, marine, geodetic, and photogrammetric surveying, each having its unique principles and applications. One of the basic tools of surveying is linear measurements, which involves using chains and tapes to measure distances. Chain surveying, for instance, is a straightforward method that uses a chain or tape measure to collect data about an area. However, it is not without its challenges. Obstacles like rivers, buildings, or uneven terrain can often throw a wrench in the works. Moving on to compass surveying, a method that uses a compass to measure the angle between 2 points. This technique is reliant on understanding bearings, magnetic declination, and local attraction. However, there are potential errors in compass surveying that must be accounted for to ensure accurate data. Leveling, another crucial aspect of surveying, involves determining the relative heights of different points on the Earth's surface. With the help of various instruments and methods, surveyors can accurately measure and adjust levels. Digital leveling instruments are a modern addition to this process, offering enhanced accuracy and efficiency. Surveying also involves the calculation of areas and volumes. Techniques for measuring area from field measurements or plans, and tools like planimeters, help surveyors to accurately determine the area of cross-sections and volumes. Another essential tool in the surveyor's kit is the theodolite, an instrument used for measuring horizontal and vertical angles. Understanding the types of theodolite, temporary adjustments, measurement of various angles, and sources of error are key to successful theodolite surveying. Contouring, or the process of determining the elevation and depression of the Earth's surface, is a vital part of planning and executing construction projects. It involves understanding the characteristics and methods of contouring, contour gradients, and using tools like GOT tracers. Lastly, we have trigonometric leveling and curve surveying. Trigonometric leveling is a method that uses the principles of trigonometry to find the height of points where regular leveling is not possible. Curve surveying, on the other hand, involves the study of curves, their classification, and elements, which is instrumental in the design and layout of roads, railways, and other infrastructure. In conclusion, surveying is a multifaceted discipline that underpins many fields. It involves a range of techniques and tools, from simple chains and tapes to sophisticated theodolites and digital leveling instruments. By understanding and applying these principles, surveyors play a crucial role in shaping the world around us, from the buildings we live in to the roads we travel on every day.